The goal of our project was to build a car that autonomously exits an enclosed area with one small opening. To indicate when the car has exited the enclosure, an LED flashes on. To achieve this, we used an ultrasonic sensor to detect when the front of the car approached a wall. The ultrasonic sensor was driven by an oscillator circuit. Once the car detected a wall, one wheel would reverse, while the other continued forward with V speed. This made the car turn. The wheel reversal was achieved by connecting one motor to an H-bridge. Instead of using an Arduino for the logic pins on the H-bridge, we used a voltage comparator. By attaching a 1000 microfarad capacitor to the output of the echo pin of the ultrasonic sensor, the AC signal becomes a DC VRMS signal. The voltage comparator compared this VRMS signal to a comparison voltage that we set with a potentiometer. If it is higher, the comparator outputs 5 volts, or a high signal. This signal travels to logic pin 1 and 2, but 1 goes through an inverter so that the H-bridge reverses the direction of the motor. Finally, we added another oscillator circuit to control the speed of both of the motors. The motor that did not switch directions was connected to this oscillator circuit through a MOSFET, and the other was connected through the enable pin on the H-bridge. As shown in the video, the duty cycle gets smaller when an object is close, and larger when the object is far. The green line represents the VRMS value. This can be derived from the AC signal by the function square root % duty cycle times the max voltage. Thus, the VRMS rises when the duty cycle is high and falls when the duty cycle is small. For the laser beam tripwire, a phototransistor was used in conjunction with a laser pointer. The phototransistor is a BJT combined with a photodiode. The photodiode converts the laser beam into a photocurrent, which is used as the base current of the phototransistor. Thus, when the laser is pointed at the phototransistor, the BJT is in the active region. When the laser is blocked by the car, the BJT is in shutoff. Initially, the LED was placed between the BJT's emitter and ground, but this resulted in the LED turning on when the laser was not blocked, and then turning off when the laser was blocked. To inverse this, we added a MOSFET whose input was taken from the collector side of the phototransistor after resistor RCC. Now, the LED lights up when the car blocks the laser beam because when the BJT is in shutoff, no current flows, and so no voltage drop occurs across RCC. This leaves the output high, which turns the MOSFET on.